Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're jumping into a fourth grade topic, multiplication by one-digit numbers. More specifically, we're going to be looking at how we're going to multiply bigger numbers by one-digit numbers. So in this video, we'll have two examples, and we're going to go step by step on how to not only set it up, but how to carry forward the multiplication process. If you have any questions about what you see today, remember you can put them in the comment box below. If you have questions about your own homework you'd like to see on this channel, remember you can visit me on Facebook at Tutor Me Senpai and tell me all about it there. When you find this video helpful, remember to leave that like, hit the notification bell, and smash the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about multiplication by one-digit numbers. Before we get into our two examples for today, there are two recommendations that I would like to pass on to you. The first one being, I recommend you know or have a good understanding of your place values. And so what I mean by that is, let's say we have this number, 1,357. Understanding your place values means that you know what that is, what that is, what that is, and what this is. So this would be the ones place, this would be the tens place, the hundreds place, and the thousands place. And you can keep going, keep going. So knowing our place values will help us structure things in a more accurate way. One thing I want you to realize is, although this 5 is in the tens place and it's a shorthand for 5 tens, you see there's only one number in the tens place. Likewise, 100, this 3 here, means that we have 3 100s, right? However, in this particular place, there's only one digit. Each of these place values only can take one digit. That is very important. I want you to remember that each place value, not only knowing their names, but understand that you can only have one digit per place value. The second recommendation is having a decent understanding of your 1 through 9 multiplication table. If you can do your 1 through 9 multiplication tables, that's going to be very beneficial when you're doing these larger numbers that you're multiplying. However, this is not a prerequisite. You're not required to be able to memorize all of this. This just is a recommendation that will make things easier. So now that we got the two recommendations out the way, let's look at our first question, and we're going to use that to kind of walk through the initial steps, and then we're going to apply those steps to our second question. So our first question says, we're going to be doing 90 times 4. Now you notice that this is set up different from here. You might actually see your question written out this way, or you might have seen your question written out this way in the past. Today we're going to be looking at this type of structure, in which we call stacking. So we're quite honestly just going to rearrange how this looks and put one on top of the other. And we're not going to forget our multiplication. So when we do it like this, we need to have a final bar, because this separates what we're multiplying by our answer. So our answer will go here. And this is what we're multiplying. So this is the structure that we're going to be using today. If it comes like this, you can easily restructure it to look like this. Now you don't have to put 90 at the top and 4 on the bottom, but it's recommending you do that. That's pretty much the convention of putting your larger number at the top and your smaller number at the bottom. So today we're worried about one-digit numbers that we're multiplying by larger numbers. So we're going to put our one-digit numbers in the bottom. And doing it this way is not just for convention's sake. It really helps us in understanding what we're going to be doing step by step. When we have our larger number on the top and we're multiplying by one-digit numbers, The number of digits in your larger number tells you something. And what it tells you is how many steps you have. So when you're multiplying by these larger numbers, 90 is a pretty big number compared to your multiplication table going from 1 to 9, right? 90 is a lot bigger. So when you're multiplying by these, we're really just breaking this up into smaller multiplication steps. So however many digits are in the top number, when you have one digit you're multiplying by, that's how many steps you have. So once again, it's very important that you get that. If you're multiplying by only one digit, your top number, however many digits are in the top number, that's how many steps you're going to have. So we're going to break this 90 times 4 into 2 steps. The next thing I want you to realize is placement. Now, remember the first recommendation was understanding your place values. I set this up in a very specific way. Not just because their example is written that way, but because we want to match up place values. So if you notice, this 90 has a ones place and a tens place, right? This 4 is only one digit, so we only have a ones place. So we want to match up ones places with ones places. And if this was bigger, we'll get into that in another video. However, if it was bigger, we want to match up the tens place with the tens place, hundreds with hundreds, and so forth and so forth. But because we're only focusing on one digits, we want to make sure that we're matching up our ones with our ones. We don't want something written like this. This is not how we do this. That's not the convention, and you might actually get confused when doing this multiplication. Now you have your setup, and you have how many steps this is going to take. But how do we actually go about multiplying this? Well, that's what we're going to do here. We're going to start from right to left. And we're going to look at the ones place first, then the tens place, and we're going to multiply the bottom number by each of these place values. So as we're lining up these numbers here, this is your ones place, this is your ones place. We're going to do 4 times 0. So your first step is 4 times 0. And then your second step will be looking at the tens place times our digit in the bottom. So it'll be 4 times 9. And if you had more digits, let's say it was a 3 here or 4 here, you would keep going until you run out of digits. You notice your steps will also keep going because your top number increased as well. So now that we talked about the setup and the steps, let's actually multiply this out and see what we get. So we have 90 and 4. And I wrote this very big because I want to kind of break this out in ways that you're going to remember this. So we have our 90, our bigger number in the top, we have our smaller number in the bottom, and we have our multiplication sign outside of the bigger number. So you see, the multiplication sign doesn't get matched up with the place value. Don't do that. Make sure it's always separate. So I'm going to actually separate these so we know how we're supposed to be looking at them. So this is going to be separating the ones place from the tens place and our tens place from our multiplication sign. So not only are we separating it this way, notice we can also separate it this way. So this is going to separate our top number from our bottom. Or you can think of it as our upstairs from our downstairs. So this is going to be our upstairs. And this is going to be our downstairs. And remember, we said that this number has to be multiplied by everything up here. So you can kind of look at this as, this is going to be our door number 1. And this is going to be our door number 2. So this 4 has to visit each and every door upstairs. So we first go to door number 1. Remember, right to left. And then once we're done with door number 1, we'll go to door number 2. So if we did that, what's 4 times what's in door number 1? 0. So 4 times 0. We're going to put that here. 4 times 0 is going to give us 0. So we put it in the ones place. We're working in the ones place. So now that we're done with door number 1, we can multiply 4 by what's in door number 2, which is 9. So 4 times 9 is 36. Now you might be tempted to put 36 here. But because we separated this off, this is our tens place. Right now, this serves as our tens place. And remember, we said when dealing with place values, you can only put one number in each place value. So instead of putting the 36 in the tens place, we're going to put the 6 in the tens place, and we're going to put the 3 in the hundreds place. So I know it looks pretty much the same, but since we already partitioned or separated this off to be the tens place, I want to make sure you realize only one digit goes in each place value. And there would be something special that would happen here if we had more doors, but we don't. So our final answer for 90 times 4 is going to be 360. Once again, every number in your downstairs has to visit each door of your upstairs. We're only multiplying by a one-digit number in our downstairs, so we're only going to have one time looking at these doors. In future videos, I'll show you how we can have more numbers in our downstairs and how that would look. But for right now, we're only dealing with one-digit numbers. So looking at our next example here, we're going to set it up the same way. So we have our bigger number, 86. And remember, I'm making this really big so we can kind of separate things out and really see what we're doing. And it's going to be multiplied by 6. Notice the 6 is in the ones place. I'm matching it up. And we put our multiplication outside of our different places. And just to make sure that we're putting it outside of our different places, let's separate everything again. So this is going to be our ones place. This is going to be our tens place. And this is outside of our tens place. So the multiplication is not a part of these place values. And we can separate our upstairs from our downstairs. And every value here gets a door. So this is our first door. And this is our second door. Remember, we always go from right to left. So door 1 is going to be your rightmost door. Door 2, and then door 3, door 4, if there are more numbers up here. So remember, downstairs has to visit each door from right to left. So we'll start with door number 1. What's in door number 1? We have a 6. So we're going to do 6 times 6. Once again, you might be tempted to put 36 here, but what did we talk about in our previous example? You can only put one number in the place value. So this is the ones place, so we can only put one digit here. We can't put both 3 and 6. So we put the 6 because 36 is made up of a ones place and a tens place. So we put the ones place in the ones column, and then we're going to put the tens place not in the tens column here, but we're going to put it up here above door number 2. Now, if you're familiar with adding, let's say you had 95 plus 6, right? When you're adding these, you know this is going to give you more than 10. Well, what happens whenever you add something and the result is more than 10? Well, you put 1 here and you would carry over whatever's in the tens place, right? So the 1 in the ones place goes here, and the 1 in the tens place goes up here, and then you would add these two numbers, and that will give you 10. So something similar happens with multiplication. Whenever we have a number that's too big to put in one value, we split it up. We can put that 3 on pause right now, hold that there, and we're going to come back to it. So now that we're done with door number 1, we're going to move on to door number 2 and multiply 6 by whatever's in here, which is an 8. So what's 6 times 8? Good. That's 48. Now you might be tempted to put 48 here. Once again, don't fall into that trap. This is only one digit big. We can't put 2 digits in here. This is the tens place. We can only put 1 digit here. So we would have to break this up. But before we do that, we can't forget this 3 up here. Remember, just like in adding, we added that top number that we carried over. We're going to do the same thing. So after we're done multiplying, we're going to add this. Add this. So this 48 would really be a 51, right? So now that we have 51 here, we can separate this so that only one digit is in our tens place. So the 1 is going to stay here, and we're going to put the 5 in the hundreds place because the tens place is already full. So you could put it here, but there's nothing else here. We don't have any more work to do, so we're just going to put the 5 here. So now, although it looked the same as me putting it here, we put the partition here. So I don't want you to get confused, because as we get bigger numbers than just 2 digits in the top, this is going to be crucial that you always are carrying over. Just like we did here, we're going to be carrying over to the next place value. Only one digit goes in each place value. So our final answer for 86 times 6 is 516. So I hope you're able to follow into these examples. Now, although our 2 examples only had a 2-digit value in our upstairs, that upstairs value can be really, really big. So however big it is, how many digits are in that, that tells you how many little multiplication steps you're going to need before you're done with your question. So take it one step at a time and make sure you visit each and every door starting from right to left. So if you have any questions about what you saw here today, put them in the comment box below. I'd love to be able to help you as much as I can. If you have questions about your own homework you'd like to see on this channel, remember you can visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done it already, remember to leave that like, hit the notification bell, smash the subscribe button, and share that video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.